Okay, let's get started together. Hello to everyone. Today I want to talk about my study. That's the interest to pay attention or my attention within it. This is about the effect of citric acid on physical properties of tamarin polysaccharide based film with herbal extract. As I said before, it is related with the biomaterial, which is the tamarind seed gum, and the medical plant added to the biomaterial film to improve some property that I want. Okay, let's see. Next, I will talk to you about four main topic. At the first, I will tell you about the background, a material-based thought, results, discussions, and conclusion will follow. Okay, let's talk about the background. Do you know nowadays there are many kinds of food wrestling development, but it still have some defect because the most of them use the chemicals in the seed polymer to be main material. So biopolymer substitution were attacked. Carboxymethyl tamarind gum was determined to use. Its prominent character is hydrophilic property, but this character is unsatisfactory for some application. So the cross-linking approach was determined to resolve the problem. The cross-linking process is the reaction between multifunctional group from cross-linking agent and hydroxyl group from starch. As you will see, sorry, this one, you will see the multifunctional group from cross-link agent and the hydroxyl group from starch is will make the reactions and got some property that will improve the character of this material. Okay, let me start. To induce new chemical bond among molecular stations, the hydrophobic ester group, this one, will substitute to the hydroxyl groups and introduce a different polymer network with hydrophobic character. We need to turn the hydrophilic character into hydrophobic character to support some property using the tunneling film. Okay, and to avoid the defect about toxicity of cross-linking agent, citric acid was used as non-toxic crossing agent. Its multi-carboxylic structure will induce the interaction between carboxyl group and hydroxyl group of starch. This interaction will improve the water resistibility due to OH group of starch. I mean the hydroxyl group of starch. And I said before about adding herbal aspect. Did you remember that? To improve some properties. Is Comorena odorata or cyanide or sapsirintine. It is a Thai traditional medical herb which used on pharmacological activities. Its ethanoic leaf extract exhibit hemosensitive property and inhibit bacterial because the presence of phenolic compound and several flavonoids. In my study work, I am interested to prepare film from tamarind gum to apply it for wood dressing, which include the antibacterial and hemostatic property from the herbal extract. And gonna be like this, or maybe the better appearance if I can. Okay, let me see about the material. And I tell you, it's just two main material. That's our carboxymethyl tamarind gum and cordorata theodoratorib. The method is the first I will get the theodorata extraction by using ethanol solution, and then I will try to define antibacterial activity of this attack, which use two main bacterial, which is S. aureus and E. coli, to prove the extract and antibacterial activity. Okay, and then I say it means the property about bad corrupting too. This activity we testing by using the cow bud mixes with the herbal extract, and we will see it by microscope about the aggregation of bud clotting. For preparation of film, I will use an acetic acid to be a cross-linking agent. Then the extract will added to improve the property that I said, antibacterial and bud clotting activity. The absorption ability would be determined, and the water vapor permeability were two. The pH and antibacterial activity of film will check it too. Okay, let's talk about the absorption ability. You see that the absorption ability will increase when the concentration of citric acid will decrease. That is related to the cross-linking in structure that I tell you before. The carboxyl group from citric acid will react with the hydroxyl group from the gum and make a new stronger coupling. That means when the concentration increase, the structure or the coupling would be stronger, and water absorption will decrease. But water vapor permeability is have the same tendency trends with the absorption. For pH, have a general term. All of the range can be used to apply for human skin. This is how herbal extract combined with the film forming base. This is due to the citric acid or cross-linking agent and hydroxyl group from a polyphenol in the extract will react together by a esterification that I said to before, and it will stick with this structure. And this is the antibacterial film. The higher concentration of citric acid show the lower zone of inhibition. In the other end, the lower concentration of citric acid show the higher of zone inhibition. It's mainly due to capability to absorb the extract in their structure. About it, to conclude, citric acid can be used as the crosslinked agent with effect to the film property in various concentrations, and the herbal extract was added to improve the antibacterial and hemostatic property. And then I guess this work can be applied to wood distinguish non-toxic and biocompatible to human skin, and advocacy to improve it for the commercial use. Thank you.